It's a spectrum strategy and engineering, or something like that.
Something like that. I like that. But anyway, you deal with single frequency networks. And so if you will, let's just dive into this presentation today and tell us, I guess you'll just give us an overview first of ATSC 3.0 and then get to explaining the single frequency platform for us.
Perfect. So you have the screen? I have the screen?
Yes, we do have the screen.
Terrific. So I'm really going to sort of start from the beginning because there's a lot of people who, they don't really, they're not involved with ATSC3 a lot. And so I hope I'm going to be touching on points that people won't really be bored. But for this discussion, I'm going to assume that you are the chief engineer of your station. Full power or low power, no difference for this discussion. You have just transitioned to ATSC3. You need to understand everything about your station's signal propagation and reception capabilities within your DMA. So there's a lot we don't know about where we're going technologically, but the one thing that everybody can be assured that we do know that we're going to see better opportunities for our stations. That's the one solid thing that we could really be assured. The ATSC3 standard is extremely solid. And now I'm going to run through it, and I don't want to take too much time, but I think there's just a lot that we have to cover. So this is a typical overview, and if you've been through any of the seminars on ATSC3, we have the applications layer, the presentation, the protocol transmission, which is a PHY layer. That's the big deal, the physical layer. And so, and on the right side, you see the HTML5 is a web page. You have presentation is UHD and protocol. Well, we know this is an IP standard. Transmission, it's an OFDM, and A322 if you feel like going into the ATSC and looking up the standard. And then we have the system discovery and signaling. Don't forget about the bootstrap. It's actually my favorite part. That's how you find the signal. So there's a lot with ATSC3, and it's really important. And one of the most complex parts of selecting the ATSC3 parameters are the trade-offs for the selectable controls. That's going to be really what I'm going to focus on. Like a simple example is a trade-off between data rate and the carrier to noise ratio. If all the capacity of the ATSC3 signal is used and the carrier to noise ratio is set to the minimum of, let's say, a -6 dB, then the available data is just limited to 1.5 megabits a second. But now on the other hand, if you switch, and if the maximum carrier to noise is like 57 megabits a second, this is just one control. ATSC has several controllable features. So if we move on and we just say that we know now ATSC3 is an OFDM based system, and hopefully everybody's familiar with it and everybody loves OFDM. And by the way, we wouldn't be talking about single frequency networks if it wasn't an OFDM. So the OFDM, the system consists of many narrow band carriers instead of one. And they can be used to carry data. Some of them are used as part of the signal infrastructure to help the receiver acquire and track the transmitted signal. The carriers that are used to transmit data, they can be encoded with a range of modulation formats and error correction coding options. Again, more options. There's a lot of options here. The modulation formats consist of square constellations, QPSK, all the way up to 4096 QAM. And there is a lot. There are out FEC codes. They're useful in certain applications that require a low bit error rate, flaw, or a high confidence in the quality of the received packets. There's a lot here. So I'm still on the PHY layer here, and the combination of the modulation format and the error correction coding, they range from a -6 dB all the way to 32 dB. So if you're using a lower modulation format and a higher density, like an LDPC code, they improve the receivability of the signal. But again, you have a trade-off, and that's in the information throughput of the channel. So again, I don't want to spend too much time, but basically the ATSC one system that we have now had a fixed throughput of approximately 19.4 megabits a second and carried to noise of 14.9 dB. So we're moving past that. So this is a screen that we should all be very familiar with. The PHY layer meets the broadcaster's need plans. We're closing up to the Shannon limit, which is a great thing, where this is, again, this has to do with choices. This is all about choices. On the left, on the bottom is low capacity, very robust. Look, the Shannon limit's approaching all the way when you go up there. And look, you can 62.19 megabits a second, high capacity, less robust. So again, the comparison to ATSC1 is a really big deal. So basically, ATSC3 provides a dense set of operating points that span a very large range of carrier to noise operating points. That's the takeaway from that one. So I'm going back to the PHY layer. I think it's important. So the constellation data representing services is spread out in time and frequency to increase the performance in burst noise or fading environments. That's the environments we live in. Cell multiplexing is the process of assigning the encoded, modulated, and the time interleaved contents of one or more services to the data cells and the OFDM symbols of a particular subframe. Also important. Now, moving on, now we're approaching, we started out the studio, and over there you can see the over the air. So now we're introducing sort of the PLPs, and that's a big deal. The ATSC3 system can simultaneously transmit several different modulation and coding formats. That's the mod codes we talk about. Each PLP can really be considered a separate encoded stream. The parameters for each of the PLP are transmitted in the beginning in the ATSC3 preamble, so the receiver is able to configure itself to the correct settings on the PLP basis. Now I'm moving on. I'm trying now to stay away from too many of the technical details. So now I'm moving on. So for ATSC3, we know about the left side about ATSC1. For ATSC3, you get more bits per hertz. The spectrum efficiency is nearing that theoretical limit. You get flexible bit rate and coverage area choices. Again, choices. They're going to turn out to be a really big deal for us. Again, on the bottom, you can see it says more bits to more places. You have multiple simultaneous bit pipes. That's the PLPs. Different choices for different broadcast services, the physical layer pipes, the PLPs, time, the layer division of multiplexing, power, and even channel bonding, a big deal, which, that's another thing that we can talk about. So not to spend a lot of time, but LDM is interesting. For each LDM layer, 100% of the RF bandwidth and 100% of the time they use to transmit the multi-layered signal, which you can see on the right, for spectrum efficiency and flexible use of the spectrum. And actually, then we have this signal cancellation is used to retrieve the robust upper layer signal first. It cancels it from the received signal, and then you start the decoding of the lower layer signal. I hope that was well understood, because again, LDM I'm a big fan of as well. Okay, so the IP transport layer. So it really speaks for itself, because we're no longer just a linear TV signal anymore. So now it's just broadcast and broadband, and you'll hear a lot about that, because that's going to enable the business models. You'll be able to have localized insertion, ads, everything else. The revenue models are not even discovered and invented yet. And now, but if you want to think about them, these are going to be the revenue models that have been available to cable and IPTV operators. That's a very big deal for us. So presentation, we know the presentation. On the left side, we have ATSC1, put that aside. ATSC3, write in a few words, better pictures and sound, and more services. It's about more services. It's about, do we have audio? Yeah, ATSC1 had not bad audio, but now we have immersive audio. The video, there's no end to what we can do with the video, and the incomparable is the word. So the SHVC, the layered video coding, I don't want to spend a lot of time, but I think this is really important. This makes what makes it possible is by enabling the base layer of service to be sent over the air and an enhancement layer to be delivered over the top to internet connected TVs. That's a big deal for us because we're in a connected world and we want to take advantage of both. So broadcasters, that's us, are relieved from the burden of carrying the full load of IP packets that you need to make. For instance, let's say a 4K UHD HDR picture, while you maintain the ability to deliver the 4K UHD HDR to the home. So that's where the OTA base and the OTT enhancement layer are added back together. Looks the same, but it's not really the same as that previous slide, because this is the application layer. This is the internet experience where you have personalized and dynamic. There's a lot more. On the left side, we have the ATSC1. On the right side, you can see, you can actually read. Hopefully you can read all that. Just bear in mind that each of the ATSC3 parameter selection has implications for receivability and for data carrying capacity. So what we're really talking about are the trade-offs once we understand that, we understand the relationship of the parameters and the data capacity of the channel. So there are other factors that affect the ability to receive a service. And we know what those are: the receive antenna characteristics, LNAs, any filters that you may use to reduce interference. And that should be normal broadcast really for us. So this is new public service capabilities. We know all about the emergency alerting. We have the extremely robust, the EAS, the wake up signal, that's the bootstrap, with the messaging, and we know what this can do. This is rich media we can send. So now there's a tornado coming to one particular area, you can send dynamic maps, you can send video clips, you can reach indoor powered receivers. It's good, oh look, we have a hurricane over there, but robust closed caption transmission, and use it for whatever we need, evacuation routes, and literally to show down to the small neighborhood. And the size of the neighborhood will be down to the size that we will. And so obviously we're working with AWARN, and AWARN is a big partner. And this is a very big deal in terms of the public service of the ATSC3. So now let's talk about really what's next for LPTV. And so what's next, because the ATSC3 standard has a wide range of settings and applications, the concept of a DMA defined around the single operating point and a single application, just plain old TV reception, outdoor antenna, it doesn't really describe the use cases for ATSC3 and your own LPTV station. So this is something that we really need to talk about. So what is the value proposition? So we want to provide more and more flexible local video, audio, datacast. Remember the word datacast. That's a really big deal because we're all becoming datacasters. And if we're lucky, we're going to have datacasting clients and customers. And these are really big benefits to LPTV, which we'll talk about. So how should an LPTV station prepare? What are we supposed to do? So first thing we have to know is that the industry has changed. The FCC sees LPTV as a mature business. They really do. They're not ignoring us anymore. LPTV, secondary system. You know what? We're not really. We're now like secondary plus. We're in a pretty good place. The FCC sees LPTV with build out plans. So I think we're in a much different place than we used to be. A typical DTV transmission plant. This is everything that you know. It's the basic transmission blocks with the transmitter. I don't have to tell you the parts. We all know the parts. External RF things, mass filter, RF combiner, transmission line antenna. This is what we're used to.
Yeah, I don't think our screen changed.
My screen sharing paused. It paused. I'm going to stop sharing then. I don't know why it paused. No, I do. Resume share. Okay, am I back?
You're back, but swap your displays.
I don't have that button. Oops, I don't have. I'm going to. Oh, screen sharing stopped. Windows closed.
Isn't this fun?
I'm going to share again, but I can't. where I'm.
Now, Ruben noticed the repeaters that was on the graphic. So repeaters in the transmission ATSC 3.0, is this for LPTV 2?
Yes, that's what we're about to talk
Yes.
to. It says I'm live.
So the last,
am I
yeah, I see your, yeah, I see you're sharing, but you've got the edit view up.
Okay. Then I'll try this again. Is that better?
Now see if you can hit that swap display button.
No, I don't have it. I don't know why that goes away and comes back. Don't have it on my. I have one giant screen.
Let's see if I can get it.
Fine. Okay, I'm approving you to. Now I see.
All right, let's see if that worked. Ah, all right. Now we have. However, transmitters may also be smaller and lower power.
Right. Actually, so I'm going back because I was in the middle of saying something. So, so what I was saying here is that this is a typical, and you see this, correct? You see the typical DTV transmission?
Yes, typical DTV transmission.
Right. So we don't need to talk about this. Everybody in this call on this webinar is experts in this. But now what we do have to, here comes my introduction, to the much smaller. Now, transmitters may also be smaller and lower power. And that's a really big deal because in a minute, I'm going to show you where an SFN for a full power station could potentially be 5 kilowatts, could potentially be 1 kilowatt. But really, in my opinion, they will not be. They'll be much smaller than that. So what you're looking at right now is actually a transmitter that's mounted, that's really working transmitter, working SFN, part of an SFN, that's 40 watts. 40 watts, you might think, wow, what does that do for me? Does it do a lot? The answer is it does. It really does. And if you put 2 of them and 3 of them, you're really customizing your contour. And think LPTV and these types of drop-in transmitters where we haven't really figured out with the FCC how they get licensed. If they're staying within your contour, and by the way, full power stations have no plans to expand their contours outside and take over an LPTV station at all. The same way the LPTV stations, this is going to fix all the clutter issues and fix the terrain issues. So this is actually pretty exciting. It really gives you much more flexibility. So VLP transmitters, very low power transmitters, they're called a lot of things and everybody gets confused. I don't know what to call them. Pico transmitters, they're called all different things. So for this slide, it's called VLP. They have less challenges because they're so much smaller. So your distance is smaller. So if you have some terrain in buildings, you're not going to get the reflections. You're solving that problem. The multipath expectations are much better. The receive site impairments, whether you're, all these things, you're getting a stronger signal. Could be SFNs are about timing and signal arrival. And this is much better, much easier to deal with. So this is something that is a very big deal for us. And I think it's going to have a big impact on LPTV stations. So now we may be in the world of multiple transmitters. And don't be scared because we'll still have one tall tower, but we will have these smaller ones, and I think very small ones. So you have to figure out your population and service goals. The regulatory environment, it's not completely solidified yet. If you ask me, how do you license this? Does it fall under the same license? It should, because we're trying to build these things, the industry, so that they're so simple, you literally drop them in. And what if we drop it in, we want to move it someplace else? Well, we want to make it so it's one package. So everything's in it. Literally, you bring up power and your connectivity to the internet is almost part of the package. So we try to do it without fiber because even that is kind of expensive. So it'll be through some other kind of a wireless link, and you just bring up your power, and it should be good. And everything should be one. So there's nothing downstairs. So you don't have the transmitter downstairs, you filter, everything is upstairs. If you think back to the picture of that very, very small antenna. So you think about financial constraints, the goal is shrink these down to nothing. And that's the goal right now. So SFN requirements, we know that SFN channels have to use the same frequency exactly. That's a big deal. They all have to transmit at the exact same time, and they have to have the same data rate bit for bit. But don't get hung up on the fact that soon you may be able to have different content and different ads, because that's also a possibility. So the benefits of a real full developed SFN, well, you know, you can see on some of these pictures, the choice of which modulation and error correction level to use is really driven by the needs of the targeted application. So mobile devices, which can only have small antennas, will require a lower carrier to noise to operate. Reception for fixed devices, like television receivers, they may have the opportunity for larger antennas, and they may operate at a somewhat higher carrier to noise level. Look, all this, we're going to figure this out right now. So SFN gain provides improved the quality of service. That's a big deal for us. Remember, I'm showing over here services, pedestrian, mobile, indoor. There's more than just 3 use cases, and we have to remember that. So again, we have trade-offs. And so by obtaining single frequency gain, service coverage increases. So there's a lot of choices we have here. So as an example, if we're looking right, we have the an LPTV SFN, zonal service capability. How interesting can this be for us, where we can put up we have one tall tower, and now we have smaller ones. One of them inside a stadium, covering a stadium. Very, very interesting for us. Think of business cases. Then you think about, wow, really make money from this. Ad zoning, significant, immediate value add. You know, there's interesting how local advertisers, now we're thinking that this is not, again, nationwide, regional, statewide. No, these are really local advertisers. And there's a lot more money when you're able to do it. And just an example, this is one example. There are like 5 different ways of doing this, but an SFN topology where you do some local insertion. So we're almost up to that as well. So what is the story? We have LPT. Should LPTV operators plan for SFN? So, you know, the answer is obviously is first get on the air with ATSC3. Once you're on the air with ATSC3, then you do your analysis. You target, what is your target audience? Is it general, specific? Is it mobile? Where does the audience reside? What are the target devices? Are they specific? What quality of service are you looking for? All those choices will impact the transmission facility. And remember, the facility doesn't necessarily have to be just one tall tower. When I say tall tower, by the way, really we're talking about towers that can be in the neighborhood of 90 feet. The cell towers that you see, the SFNs on the lower power ones, will look exactly like the cell tower antennas and repeaters that they have. So we'll have more choices. You really will be able to define the service area. Until now, based single stick, well, we're moving past that. So again, this is about what you need, who your clients are, and how much power do you want to put in what direction. So now I'm just going to show a few examples on potentials. So for ATSC1 transmission, determining coverage for all of us is a fairly simple process, because ATSC1 has a single operating point. And we know it was defined by the data rate, the 19.39 megabits a second, the carrier to noise ratio of almost 15 dB. But if you use this single operating point with some assumptions around an outdoor antenna and receive capabilities, the FCC developed a methodology to find theoretical reception contour for each DMA. So we know that. We're very clear. This picture, ATSC1. Now let's move on. We have ATSC3. So I'm jumping back for a second. This happens to be Seattle. Okay, so if it looks familiar to anybody, that's Seattle. So now we're in the same exact place. And now this is ATSC3. By the way, this is ATSC3 in Seattle. So the only thing that I really want to take from here, understanding how a signal will be received, it's much more complicated, because when you define the ATSC3 standard, the ATSC considered and adopted a lot of different technologies to make the standard applicable for a wide variety of possible real-world applications. So of course it includes the standard outdoor TV case, but also indoor reception, mobile reception, portable, that's pedestrian reception, and you have indoor reception, but you also have deep indoor reception. So the only thing I want you to look at over here is, this is CRC predict, by the way, for those interested, and look at the cover, look at the population. That's the number that you should really look at. So this is the prediction is 4.4 for this. And this is just the same as the ATSC1, which is really based on a rooftop antenna kind of. So now we're looking, this is now ATSC, we're finished with ATSC1. This is ATSC3 fixed. And now for argument's sake, stare again, it's 4 million is the population. So this is a fixed population with a single tall tower. And that's what we have. Exactly 4 million is the population covered. And now we're, again, ATSC3, we don't have to say it anymore, but this is the coverage for portable outdoor. Portable outdoor is a little more difficult because let's say it's the phone that has a receiver built into it. So now you have to take your head into consideration. You have to take your, are you 6 feet off the ground? You're not much more. So now the population covered is 2.5. That's a little bit of a difference. If you keep moving along, and now this is mobile. Mobile has its own challenges. So we went down a little, we're at 2.3. And if you look, we're still sort of using these circles for obvious reasons, because it's a little easier than us now throwing the terrain, which you see the terrain. So there are a lot of places that are not getting coverage. We all see that. So we don't have to specifically, you know, and you can see by the brown, you see the terrain is really, really, this is a challenging terrain. And there's a 2.3% of the 2.3 million people covered in mobile. Now, wow, look, we now have, we just added 3 5-kilowatt transmitters, and look what we have here. Now we have 2.8 population, and this is for mobile. And really, this is just those 3 5 kilowatts. That's what we did here. We have the one main and we have the 3. And so yeah, this added some, and now we have the 3 5 kilowatts plus, I think it's 4 1 kilowatts in, obviously in what we consider the strategic locations. And now we have 3.8 million people. So there's really, really a big difference here. And if you could, in your own mind, interpolate into the lower power for LPTV, you get the same benefits, exactly the same benefits. So now we move on to what about the coverage probability for portable indoor for ATSC3? So remember, indoor is really challenging because indoor is, there's an antenna, or it might be, where is it? Is it in a room that's an indoor kind of a, not right by the window? So the population covered is 1.6. Not too great, really. But if you now add those 3 5-kilowatt transmitters plus the 4 1-kilowatt fillers, look what you did to the population. Now you have 3 million. And that's a really big deal because some of the business use cases that you may have, you may want to do this. So this is something that I think is really important for us. And here we have portable indoor. Portable indoors, 3-kilowatt transmitters. And remember, portable indoor now. And now we have basically 2 million people. So these are really just meant to be examples and showing you the benefits of potentially of what we really can do. So now if I just to sort of reiterate, so what you see here is obviously we're trying to boost the signal strength, but we have deep indoor, we have fixed indoor gateways. Fixed indoor gateways are interesting. Indoor nomadic, which is portable, outdoor mobile, fixed indoor, outdoor. There's so many cases and everything is a trade-off. So there's a big gain in consumer service by lower bit rates, and you get a slight gain in consumer service with the higher bit rates. So there's a lot we can learn from here, but what does this mean for LPTV? So we know what it means. So for news, we're gonna now, we have our own viewers, hyper local stories as an example. Promotions, well, we know, cross-promotional vehicles, customized content, the mobile, the younger, larger audience. It's a big deal because things are changing. So operations engineering, well, it's multiple transmitters. That's okay because it's the same big one. And then we have the sales. Well, now you're selling bits. Bits are for sale. That's what we'll be doing. They'll all be there. So the last slide I have here is what is the action plan for LPTV? So the first thing is evaluate your own station possibilities. Obviously, get on the air with ATSC3 when you get on the air, and then do your own evaluation and look at the possibilities. It's what you want. You want to support the ATSC3 and this transition as an industry we want to begin, and this will soon be routine. And you'll see a lot of these SFN drop-ins popping up. We want to be more visible to the FCC. We want them to know what they want us to make full use of our spectrum. It's about spectrum. They want us to. If we tell them, you know, we need to put in 3 SFNs, but we're doing it in our own spectrum, that's good. That's what they want. So how do we do this as all together? We all need to be active in the ATBA, and that's a really big deal because that's our voice for DC. And that's it. So thank you all for listening.
Definitely appreciate the plug. Louis, SFNs, I think, were very misunderstood in the beginning. And as we talked about this from a regulatory standpoint to the FCC, a lot of LPTV people thought, oh no, you know, these full powers are going to take our frequency, our channels to make their SFNs. But that's not true. An SFN is on the same frequency as the big stick. And the same thing from the LPTV, our LPTV stations, we can make use of single frequency networks just as well. Is that correct?
It's completely true. Yeah, this is not a spectrum grab by full powers to try to expand coverage. This is not meant to expand coverage. This is meant to fill in the missing pieces to our coverage, just as LPTV doesn't have a real circle. They follow terrain and clutter, and same way can be used to fill in the missing pieces. So there's still a lot of work in regulatory because we do not have answers. You know, there are some open issues with the commission, and we're asking them the questions. We want to test, for example, so we want to begin to test out SFNs in different locations. How do we do it? Is it 1 STA? Is it, you saw, is it 3? Is it 5? Is it, how many is it? So, you know, we're hoping that the FCC, and we're telling them, we want to make their work easy for them. It's the same channel, it's the same frequency. It's within our licensed coverage area. We shouldn't even have to license it. It's already licensed. So that's the goal. The goal is really to make it simple for them. They're busy, Paperwork Reduction Act, all of that.
And they do. They love simple. But the big message here, the big takeaway of the day is that LPTV can do this also. And I can remember putting up brand new antennas on ATSC one station and being very disappointed with nodes or areas that I didn't have coverage in. Wow, if I had this opportunity today to be able to fill in those gaps in my contour, would have really been a game changer in bringing in some neighborhoods that we never got access to because we couldn't get into them. But it is at our question and answer time. So Louis, if you've got time to answer some questions, let's spin some questions up. And so can I get the slide information by email? I can show this to interested parties in my market. I'm sure we could, this entire presentation will be available so you can see these slides. It's over on our Facebook page, and we'll have some links in our next newsletter also. So I don't know if this is a slide deck you want to actually just put the slides, or whether you want to just keep this with a presentation with us.
It'll be an ATBA presentation. So we'll, I guess, we'll figure out how we want to disseminate it. But yeah, I mean, I would like this is about education. It's really about education. And that's really why in the beginning, I really spend time on the physical layer of ATSC3. And there's a lot that I didn't say, like, I'm talking about squeezing into this little kind of a drop-in SFN. There's more we have to put in because SFN really is complicated in terms of it's about what time do you catch the signal and what time they all have to talk to each other. So within that same box, there'll be monitoring equipment as well, but that's the goal. So no, this is about education. I'm not here to hide any of this. So I think we'll fix it up, and then Lee, you'll figure out how you want to either show it or disseminate it, etc. Yes.
All right, here's a question from Roy. My understanding is that there is no mechanism to add SFN cells as an LPTV station. Full powers can add gap fillers, et cetera. Is there anything ongoing at the FCC that will allow LPTVs to license gap fillers?
So we're not really calling them gap fillers. So this proceeding it's not one that the FCC asked for. It's the broadcasters asking, and again, it's very logical because we have a contour, a licensed contour. So we're not necessarily calling them gap fillers. We're just calling it, a mini SFN or whatever it is. But yes, so this is something that's ongoing at the FCC, and we intend to put LPTV in the same position as full powers for this.
All right, Ruben asks, clarify SFN programming. Can I do data stream in one repeater and TV programming on another repeater?
So it's a great question. The answer is you will be soon, but not yet. At this point, there are ways of doing it, and that's where the LDM comes in. So at the first, for the first couple years of ATSC3, it's going to be the same programming and the same ads. But as we begin to get better at what we're doing, there are all these different techniques that will be available within the ATSC3 standard. So yes, the answer is yes, but not yet. Let's first get ATSC3 on the air while we optimize all these other kinds of techniques to get the separate zonal transmission.
All right, our next question comes from John. Do you expect we will have signal addressability for OTT type subscription services?
I think that's also within the standard, and it should be. I believe it will be. That's the goal. The goal is to get us tied in with broadband and let us take advantage. And what's the next step after that? So yes, we tie in with OTT. Following this, again, once we're all set and finalized with ATSC3, the next band is how do we coexist with 5G? That's going to be the next big challenge, which is already working. It's convergence. It's the numbers are beginning to work out, and it looks like whether we're actually working on the same standard with them. The 5G people are so big, they literally don't care about or don't know about our standard. We're writing into them, and I think that we will find that we will have convergence with them. So, that's a very, very exciting technology, but we don't want to spend too much time on it now. We want to make experts out of all the broadcasters in ATSC3 right now.
Right. So Richard asks, now the Spectrum repack is over, have you heard when the FCC will open for LPTV CP licenses? I desperately need LPTV license.
Yeah, I'm not sure. I don't know. I don't know. Who knows? There's a new FCC and things may move quicker.
That is a good question. A good reason to stay in touch with the ATBA, as hopefully we can work on those things and hear about those things soon. So once again, that's all of our questions at the moment. So if you've got a question, be sure and go ahead and ask it now before. Okay, here we go, Mick. Will reception change of stations vary their mod CODs dynamically?
So everything changes. That's a great question. The mod cards will change the amount of data you can carry, and everything changes. So that's why the determination of what you're aiming at in terms of what type of devices you're aiming at, what type of service you want, what type of, are you looking for 4K? Are you looking for just UHD? Whatever you're looking for. So yes, so we're finding, because at Sinclair, we have a whole bunch of stations have already transitioned. And there are, you may have seen it, I sort of skipped over the words, but within it I wrote, there are a lot of knobs to turn. And in some ways it's too many. So I think what we'll find is that we will standardize as stations come up, and it'll be very soon. So the more, and by the time, the bulk of the LPTV, there will be, here is what you should use normally for this, et cetera, et cetera. It'll be much easier. Right now, literally there are thousands of combinations. and it really is, it's too much, and we want to make sure we don't get in trouble, and and we want to make sure that people receive whatever we send, especially since we'll be in a new world where in most cases they're paying us for reception.
Right. So we do appreciate you guys blazing the way for us at Sinclair and figuring all of this out as we come along. But just to let everybody know, we can switch today to ATSC 3.0 as LPTV stations, and many of our folks out there do have maybe multiple channels in a city and can go ahead and light up an ATSC 3.0 to start working with those different products or mods.
Thanks. My one last pitch is really, as a group, we are so much more powerful. Yesterday I was at a meeting. It was it's called WRC 23. It's for the WARC 2023. It's an FCC advisory committee, and interim chairman Commissioner Rosenwurzel was there, and people were introducing themselves, and just by us staying together is a very, very big deal. And so the ATBA, again, is a body that's comprised of a lot of different stations, small and large, and very powerful, and we should not negate that. So I really advise that everybody, especially now that we're moving towards transition, should become much, much more active. So thanks for the opportunity.
We do appreciate that. And we've got, actually we're about out of time, but we've got another question that just popped up. From Ruben, what receiver is best for ATSC 3.0 testing? So what TVs, receivers do you know of out there that you can pick up, I guess off the shelf, Louis?
I wish I could really answer that. I think they're about to come. Really, just watch the news. Look at like the CES that didn't happen, but it did happen, but it was virtual. There are a lot of receivers that are now coming off. You'll start seeing dongles and you'll start seeing receivers. But right now, I can't go to Best Buy, I can't go to Costco, and I can't buy ATSC3 receivers. But you will be there'll be an avalanche of receivers coming through now. But and that's, by the way, and a lot of that will be the responsibility of the ATBA to disseminate that information. So just watch the newsletters.
Right. So we are seeing some of those start to pop up and should be coming to market soon. Wanted to share this screen real quick to show you some of our sponsors, the ATBA, that are helping keep the lights on and funding, and our look and watch on the FCC as they transition to the new FCC. And we would like you guys to, if you're interested in sponsoring the ATBA, we'd love to speak to you, or joining the ATBA. Just go to our broadcastingalliance.org website and join with us. And we look forward for everybody that's on this particular webinar joining the ATBA for 2021. And just to give you an idea of some things coming up in October, we are working on an event on Monday night, October 11th, as our LPTV reception at NAB. Hopefully, we're all going to be live and get to see each other again. Long time coming. So we're glad that hopefully things are calming down in the virus world, and for us in snowstorms. But anyway, Louis, Libin, we appreciate you being with us, and being also on the board of the Advanced Television Broadcasting Alliance. And we look forward to next week. And if you do have an idea for a seminar or webinar or something that you want to learn about, or somebody that you want to hear from, or if you would like to be one of our presenters, please let me know at info@broadcastingalliance.org. Love to hear from you, and love to get some of these on the schedule so we can try to do these every week or every other week in the coming days. So Louis, any last words?
No, I wish everybody good health and good luck with the transition. And just stay in touch with us. If anybody has any questions for us, for Lee, for myself, don't hesitate. That's what we're here for. Thank you.
All right. Well, thanks, everybody. We'll see everybody next time.